We'll just start with our first speaker, who's Jessica McCarthy and Vilaveko Parnu, uh, and they will present The Arctic on Fire. I think Jessica's speaking first. It's all yours, Jessica.
My name is Jessica McCarty, and I am an associate professor of geography at Miami University in the US. And I'm speaking here today. I'll co-present with my colleague, Vilaveko Parnu, who's from the Finnish Environment Institute in Helsinki. We want to talk to you about the current situation of wildland fire in the Arctic and the Boreal. Some key takeaways for the audience and for policymakers are that there is an increasing trend of fire activity and fire emissions above 60 degrees north globally since the mid-2000s. In fact, we see more fire at 60 degrees north sometimes than we do in the temperate zone. There are intercontinental transport of smoke and pollution that affects the Pan-Arctic already. This is not a future problem. And that future Arctic fire regimes will be more extreme, and this is mainly due to climate change, but there are solutions and pathways forward. In a review paper that our expert group on short-lived climate forces of the Arctic Monitoring and Assessment Program published in 2021, pulled together from more than 250 peer-reviewed publications globally, we found 10 risk factors that are increasing Arctic fire risk and affecting the Arctic fire regime. Of these 10, 9 show an increase in fire by mid and late century. So this increase is happening now. And as you can see, there is a symmetry across the Arctic. The Arctic is connected. So what is happening in North America is also happening across the Nordics and Eurasia. It is not just our group that has found this. So Grid Arendelle published a really nice report in 2021 showing that climate change in the Arctic is also affiliated not just with increases in Arctic fire risk, but also black carbon concentrations and deposition. As is visualized here, the purple shows our black carbon concentrations throughout a seasonal distribution of the red and slightly orange wildfire activity across the Pan-Arctic and Pan-Boreal. And that this black carbon is also affiliated with continuous permafrost extent, and what's really important for thinking about solutions, peat extent. Fire emissions are really important at the high latitudes. Extreme fire years, like in 2020, can outpace anthropogenic sources of black carbon, including things like flaring, emissions from transport, and even residential. And these sources of black carbon originate within the Pan-Arctic. Here in this bar graph, we have split it by whether or not the fires are north of 60 degrees, which is a slightly lighter color, or north of 65 degrees. So this can be quite significant during extreme wildland fire years. While there is a lot of fire happening throughout North America, and sometimes even extreme fires, as we have seen in Sweden and Finland and even Greenland in 2017 and 2019. The majority of our fires are originating from Siberia and the Russian Far East. In fact, about 68% of all Arctic fire activity originates from the Russian Federation. And with that, I'd like to turn this over to my colleague, Vilaveko.
Thank you, Jessica. As introduced, I'm Vilaveko Parnu from the Finnish Environment Institute. And a very recent example of these unprecedented fires in the Arctic is the activity in Alaska just this summer, as reported by Rick Thoman here. 1.3 million hectares burned in Alaska, which was the 7th highest burn area since 1950. And furthermore, Southwest Alaska witnessed unforeseen amount of tundra wildfires in that region. So we're getting new areas who are experiencing these extreme wildfires every year. Next slide, please. The smoke from these fires doesn't only affect the neighborhood of that fire. Finnish Meteorological Institute has a measurement station in the center of Finland, and they've been over there able to detect smoke coming from wildfires originating in Russia and from Finnish point of view beyond Moscow, so quite far away. Furthermore, smoke from fires from North America have been detected in Europe. So we can see that the smoke from these wildfires can travel intercontinentally and really large distances. And next slide, please. Therefore, we need pan-Arctic collaboration to be able to meet the challenges of the increasing fires in the Arctic. This means large networks for collaboration, research and sharing of new technologies, and taking into account how human activity impacts these fires now and in the future. Our project, the APC ICAP, has begun this work by organizing webinars between European and North American fire experts already. And we plan to build on these activities and networks to go forward to fight the increase in Arctic fires. Thank you very much.